Hello, welcome everyone. So now we are doing question number 2 of Spec Maths Exam 1. This question is evaluate 2x plus 1. That's a anti-differentiation we have to do, and it's a 3-mark question. I'm pretty happy with this question. It's very easy, I think, to gain these 3 marks. So we just have to go and integrate it 0 to 1. 2x plus 1 over x squared plus 1 dx, and we can rewrite it like 2x over x squared plus 1 plus 1 over x squared plus 1 dx. Okay, so what we can do in this one, the first one here, if we see that by substitution, you could do that, or some people are pretty good doing directly, but if you are not sure how would you handle that, you can say let u is equal to x squared plus 1, and then du would be equal to 2x dx. So if we do that substitution, the first integral would be 0 to 1. 2x over x squared plus 1 could be written as dx. 0 to 1, let's name that as a 1. Okay, so you can handle everything together, or you just you see this would be du over u, and that becomes a log u, natural log or log e base. I should write that notation, log of e u, and then log of eu can be written in terms of x. It would be I did not change the limits yet, so let's not do that in terms of the u. So just say this would be our log e x squared plus 1. So now I can apply the limit on it, 0 to 1 onto that. So this will give me, or you could, if you want to apply the limit here, then you have to change that into the u form as well, because when x is 0, u is equal to 1. When x is 1, u is equal to 2. So that's also possible, right? In terms of the u, you would like to do it. But if you want to leave that in terms of x, that's also fine. So that will be log e, 1 plus 1 is 2, minus log e of 1. Okay, so this 1 over x squared plus 1, that's what we know is a tan inverse of x. So we get log e1 is 0, so that becomes 0, and log e2. So now we say 1 implies this one would, the first one would be, so that means our integral 0 to 1 to x plus 1 over x squared plus 1 dx should be equal to what? The first integral gave us log e2, and the second one we can write it as plus tan inverse of x from 0 to 1. And then we say apply the limit, we get log of 2, and that gives you plus tan inverse of 1 minus tan inverse of 0. Okay, so tan inverse 0 is 0, tan inverse 1 is positive. This is first quadrant, so it would be log e2 plus pi on 4. So that should be our answer. So that's worth it, 3-mark question. So that is our answer for this one. Now let's look at question number 3. A company produced a particular type of light globe, and you always have to look at what are the important information there. That is the hardest thing for kids to identify. What is the what are the important things? So let's see, we highlight those ones. So it's a normally distributed with a mean, and it's known that standard deviation is customer complaint the shining globes were lasting less than 200 weeks. Okay, so we decided to investigate that complaint, and there is interval that given, which is the same as this one. Write down the null and alternative hypothesis for one tail test that has conducted the investigation, the claim. So what is that? We are saying the null hypothesis would be H naught is when the mu is equal to 200. And alternative would be when the mu is, because that's where it's less than 200. Okay, now we need to find the p-value, correct to 2 decimal places, 3 decimal places for the test. Okay, so we know that the expected value of x, which is the mean, is 200, right? And then we have the standard deviation is, we're going to work out the standard deviation. Standard deviation is equal to, we use that standard deviation of the mean is equal to sigma over root n. So that is 5. So n is 36. So we get 10 over square root of 36. So that gives you 6, 10 over 6, which gives you 5 over 3. Okay, now we're going to find out the p-value, which would be equal to, we say, probability of is x bar is less than 195. Okay, so given that mu is 200. So what does that mean? That means we could rewrite that as probability of z, which is less than 195 minus the 200 is mean over 5 over 3. And if we simplify that, so that will give me probability of C is less than minus 5. So that gives you -3. So Z is less than -3, which would give us is the probability would be, so less than -3, which would be 1 minus 0.9973 divided by 2, which would be equal to 0. I need to just work that out. So that would be so 0.000000000 0.9973 2 0 0 0. And then we have to divide that by 2. So divide that by 2, 0, 0, 0. Okay, so that's 0.00135. And then we need to do a decimal 3 places. So that means that should be equal to 0.001. Okay. What should the company be told if the test was carried out at the 1% of the level of significance? So that means 1% mean 1% is the same as, say, 0.01, right? So that means p-value is 0.001, which is less than 0.01. So there is a strong evidence that we reject H naught. So reject the null hypothesis. Okay. Now that's good. Now we'll look at the next part of the question, which is 3C. We have The company decided to produce a new type of light globe called Globe Plus for an approximate 95% confidence interval for the main lifetime. Okay, so we need to do now the 95% confidence interval. So we know that the standard deviation of X bar would be what? Sigma over root n, which is, we're saying here is the mean is, and the standard deviation is for the population is 10 week over root 25, which give you 2. Okay, and then we are going to do is the interval, which is using that formula. We know the 95% confidence interval would be the mean minus 95 mean 1.96 times by sigma of square root n, which is 2. And then we have 250 plus 1.96 times by 2. Okay, so that's our 95% confidence interval. Confidence interval is, okay, and then we need to just do a bit of multiplication and working that out. So 1.96, so that would be 392, and then you go to 50, which gives you 246.08, and then we also go to which is 250 plus 3.92, which gives you 253.92. So that is the 95% confidence interval, and give your answer to 2 decimal places. Just make sure you answer that correctly in there.